What is up, ETHDenver 2024? How's everybody feeling today? Incredible. Wow, we did not expect this amazing turnout. Hundreds of people in the audience. My name is Sean Conrad. I do DevRel for Secret Network.
And I'm Alex. I'm also doing DevRel at the Secret Network Foundation. Welcome.
Welcome, everyone. And we're very excited to be presenting today our talk on Trustless confidential bridging with Secret Network. So what is Secret Network? If you've never heard of Secret Network before, we're the premier layer 1 privacy chain of the cosmos. We've been around since the beginning of the cosmos, and we now have an EVM developer toolkit where our tools can be used on the EVM seamlessly. And we're extremely excited to be presenting that technology for anyone who's here today. You're going to be able to learn how to drop our code into your code with proxy contracts with a single contract address.
So, now that you know about Secret Network, the question is, how do we bring in the privacy tech from Secret Network and confidentiality tech into the EVM space and into other chains? The way we do it is something that we call Snakepath. Snakepath is a cross-chain trustless bridging solution that leverages Secret Network's privacy-preserving contracts. The idea behind it is we can use this to basically build any dApp that requires confidential computation on the EVM. Hold on, we're not done yet. We're definitely not done yet with Snakepath. It allows you to do a broad range of things. It was originally developed by community members, and it was such an amazing solution that it's now being used to do a whole bunch of things in secret to bridge privacy-preserving computations into the EVM. Idea behind it is we will have encrypted, and we have encrypted payloads and call data basically that we can bridge into EVM. So for you, this is the most easy way to use encrypted payloads and call data and to leverage this to build your privacy-preserving dApp or just to leverage confidentiality as you want.
Yes. There's two main things you can do with Snakepath, which is, as Alex just stated, any encrypted payload you can imagine. So you can kind of just think of Secret as like a side chain where you can have composable privacy on the EVM. Or two, we've developed something called Secret VRF, where you can have on-chain verifiable randomness that is faster and cheaper than Chainlink VRF. And we're super excited to do a demo today to show you exactly that. And if anyone here is in the Link army, please come for us afterwards because we want the heat. We're bringing the spice.
Exactly. What we wanted to do is to essentially have something that's super easy to use for you. Chainlink VRF has a lot of complicated stuff. For Secret VRF, we want to have something that's super easy to use for you. We are deployed on a lot of test nets, for example, on Ethereum Sepolia, Polygon Mumbai, Optimism Sepolia, a bunch of test nets. We are also deployed on a lot of mainnets, Ethereum mainnet, Arbitrum, Optimism, Linea, Base, you can name it. If you have chains that you want to have support for, and it's not supported yet, you can check out the docs to see if your chain is supported yet. If not, please come to us. We're really happy to extend our support for these chains as well. The thing that you need to take a look at is basically one thing is just the gateway address. That's all basically that you need. The gateway address is all that you need to call to leverage the full privacy-preserving features of Secret Network. Snakepath will do the rest for you, and we have extensive tutorials for you to make the most out of this.
Yeah, so if anyone here has worked with Axelar GMP before, you might be familiar with pointing to gateway contracts. Same exact idea. We have these gateway contracts that abstract away all of the complexities of working with Snakepath. All you need to do is point your smart contract to these addresses, and you'll have access to these private computations as well as secret VRF.
So now, the only question now is, since we want to make VRF very simple for you using Snakepath.
Nice.
Question is, since Snakepath uses a broad bunch of cryptography to pull this feed off actually, what we wanted to do, and Secret Network, is the following. We want to make everything complicated just go away, abstract it away from you so that you as a dev can only, concentrate and focus on something that you just drop into your contract, less than 10 lines. You drop in secret in less than 10 lines into your code, and we abstracted everything else that's complicated away from you. So this is what we're going to claim. We're claiming essentially that we have secret VRF in basically just 10 lines of code for you. Nothing else that you need to do. Drop in the code, and it will all work. Of course, if we support you on your chain. If not, please come to us afterwards. Shoot us an email. Shoot us whatever, or come to us when you see us.
Yes.
So now, for this, Sean?
We're going to do a brief demo where what we do, we're just going to show how easy this is to actually work with. So if you've ever worked with Chainlink VRF before, you might have gone through their docs. They have a contract that's like it's already open in Remix. We've already uploaded their contract. We're going through Chainlink's exact docs to request randomness. You receive 2 random numbers, and then we're going to do the exact same thing with secrets docs and show what it's like to receive 2 random numbers and show that you can do it for a fraction of the cost and speed of Chainlink VRF. And what we're so excited about this is Secret is a Cosmos chain, and one of the big promises of the Cosmos is interoperable programmability with these blockchains, right? But right now, we're at a state where we haven't seen a lot of interoperability. Everyone's kind of their own chain. Everyone's kind of siloed. We found a way with Snakepath to bring this not only to IBC, to other chains on the Cosmos, but also to Ethereum in a way that's extremely accessible and also familiar for EVM devs who've worked with something like Chainlink before. So you can do this for encrypted payloads, but you can also do this for VRF, which is what we're going to show right now with our on-chain verifiable random number generator. So what we have is we have 2 instances of Remix open. One is Chainlink VRF's code from their docs that requests 2 random numbers.
Can you make it a bit
yes, make it a little bigger.
isolated?
Whatever the people want. If there's any requests from the audience, please shout them.
You can read it. It's perfect. Now it should be readable.
All right.
Yeah, perfect.
So we have 2 instances of Remix. One is for Chainlink VRF's, their docs, and then we also have one in Secrets docs. And both our resources are at the end of these slides. You can pull this up, and you can go right to this documentation if you want to do this on your own and experience how simple this is. So we just pulled this straight from Chainlink's docs. We took their contract. We compiled and uploaded it to Sepolia testnet, and now we're going to do that with Secret VRF as well. So first, let's just request randomness with the Chainlink VRF contract.
Let's confirm, and let's see how fast this is.
And then while we wait for that, what we can do is go into the secret contract. Do you want to explain this code really quickly, Alex?
Absolutely. So, the important things that you need to look at here is the following. You can go up. Yep, exactly. So, at first, as we claimed, we're claiming to get secret VRF in just 10 lines of code for you. First, what we need to do is just define an interface. In this case, we're defining an interface for you to request randomness. So that's the interface that you basically implement, and that's what you're going to call on the gateway contract. You're requesting randomness. That's it. Basically 3 lines, that's it. Then we're going into our sample contract. Now the next line comes in, which is just you defining the gateway address. In this case, we use a storage variable. Then on the next stage, we go a bit lower, down here, to set the gateway address. In that case, what we do is we just, you basically do it as a contract owner. You set the gateway address to be that's pointing towards the VRF gateway.
I can show that right now, too.
Yes,
so
of course.
If you go into Secrets docs, we have all these gateway addresses for both testnet and mainnet. And as Alex stated, if you have a chain that you want to work with to request secret randomness and you don't see it listed here, just DM us, and we will get it up and running so that you can have it for your chain on the EVM. We're doing this for Sepolia, though, just to match and mirror what Chainlink's docs do. So all you have to do to work with this on Sepolia with Secret VRF is copy the gateway contract address, go back into our instance of Remix, and then just set the gateway address for our contract. So I'm just setting the gateway, calling this function, and confirming the transaction. And then from there, we are able to request randomness. Let's just make sure that our Chainlink transaction went through already. Okay, great. So we're going to look at this Chainlink randomness request in 1 second here. We're going to look at this event. But first, let's just request randomness with secret VRF. So if we go back into our Remix instance, let me make sure the gateway transaction went through. Okay, great. So we have this transaction showing that our gateway was set successfully for Sepolia testnet. And now we can just request randomness.
Of course, you need to make sure to pay enough gas
Yes.
for the callback. That's what you just basically send in a little bit of extra gas to pay for the gas on the way back. That's what we define with the callback gas limit. That's everything of this is explained in the docs thoroughly, so you can make sure to not miss this. And
all right.
it.
So we just requested randomness. Let's see if it's gone through with MetaMask.
It's pending. Let's see.
Right. And now at this point, the amazing thing about this is works as quickly as the chain on which it's deployed. So we're just waiting for this to go through with Sepolia, but whatever the block time.
In this case, we actually didn't pay enough gas. Make sure to pay enough gas, guys. The contract doesn't like it if you don't.
Okay.
So now we're being a bit more generous. By the way, the exact formula on how to calculate the gas fee that you need to pay for the way back is also mentioned in the docs with an extensive tutorial on basically on how to automatically calculate it.
It's going to speed this up. Oh, it went through. All right.
Perfect.
So
now, while we're waiting on this, I can actually explain the other part of the code, the last bit that we just did. Can we just switch to the screen again? Yes. So now, basically, what we just did is execute the last part, which was actually requesting this randomness test. And as you can see, this basically are the last lines that we need to do, which is first just define our VRF contract. Next, we are requesting our randomness. We're just basically calling VRF contract. Make sure to also give over the value, so the contract actually gets to have its callback gas. And lastly, we just define how many words we're going to have, how many random numbers you're going to request, and how much the callback gas limit is. And next, for this test, we're just emitting a request, a log. Exactly. That's it.
all right, 1 second here. Oops. Are these the same instances? Give me 1 second.
See, the transaction was so fast, we even lost track of how fast it was.
Let's make sure I have the correct contract address up. Here we go. Turned it yet?
Yeah,
Grab your computer.
yeah. Let me get that one as well.
All right. Our core dev is checking on the relayer to make sure this went through. So one of the amazing things about secret VRF with Chainlink, or with Snakepath, is that the relayer is trustless. Everything that's trusted that's happening, it's all just happening with the smart contracts. So you can design a relayer to actually put the transaction through. You could do it manually. We just have one relayer spun up right now for this demo. But basically, the only way this could fail is if the relayer itself fails to pick up the transaction. But the smart contracts themselves are trusted and verified.
So that means that essentially you don't need to trust the relayer. In the future, we'll have multiple relayers relaying this. So as this demo basically just runs on one relayer, and we're improving relay performance every time. We want to make sure basically that in the future we will have multiple relayers relaying this, but you don't need to trust the relayers. That means you only trust the gateway contract that lives on secret network. That's the most important thing that you need to know.
All right. Okay to request? Give us 1 second. Does anyone have any questions on what you've seen so far? While we spin up this relayer. Yes. It goes as fast as the latency of the blockchain on which it's deployed. So like what we've been seeing on Sepolia testnet is it takes about 2 blocks for the randomness to be returned.
Try it again.
Okay. So for example, if we look at the chain link randomness request, we can see that it took about 5 blocks from the initial request for randomness to when it was returned. We see it was block 74, it was returned block 79, and then we can go in here, see the transaction fee and the gas price. And then if we go into secret VRF, we have this request for randomness. Going through. Yes, let's see. All right, we're just going to try this one more time. See if it's a relay error. I'm just going to compile and deploy a fresh instance of the contract.
As you can see, and that was one of the most important things for us, is essentially this stuff is so fresh out of the printer press for you that we specifically wanted this to show you at ETHDenver so you can try it out in the hackathon. That was one of the most important things to us. So as you can see, you're basically right at the forefront of what's going on and what we're doing. And that's why we wanted to get this into the hands of you as fast as we can.
All right, deploying an instance of the contract. And then we're setting the gateway once more. All right, set gateway was confirmed. And now let's try requesting randomness.
Let me see if it pops up on the relayer.
All right, we got the relayer open live.
Trust.
You're connected to the Wi-Fi?
Yeah.
All right. Just gonna make sure we pay enough gas.
No, you didn't pay enough back. Matter, it was actually.
It was.
It was no. You can't do it like. Definitely go down. Press randomness. Use the other function. This one, yes. Put input. Yes, exactly. And you can.
And how much here?
100.
1,000.
Otherwise, the transaction will fail.
All right, I'm gonna try this one more time.
But as you can see, this is the most important thing. Actually, you need to actually also pay enough gas for the callback, and you need to define this one. But this is all mentioned in the docs for you, so we're basically showing you on what not to do right now. And for the demos, we're actually really happy to just help you out because this is so extremely easy to do And we got more infos for you for the EVM Toolkit docs, for the demo that we have here, and a QR code if you want to do for more for the docs.
All right, thank you so much. We've been Secret Network. Stay tuned for our EVM toolkit to learn more how to use this. It's still just being worked on right now as we speak, but it's really incredible, and we've seen how it's faster and cheaper than Chainlink VRF and other VRF solutions on chain currently. Thank you so much.